Hi, this is Alex from devstories.eu. Langflow, episode 13 of 15. You might think of a node as a simple block box where data goes in, a function executes, data comes out, and the node instantly forgets everything. But what happens when your pipeline requires a node to initialize a complex database connection or track how many items it just processed before yielding a result? That requires breaking out of simple functions and using advanced component hooks and execution. A common assumption is that components are strictly stateless operations that just evaluate inputs. They are not. A component is an instance of a Python class, and it goes through a specific lifecycle managed by the internal execution engine. During this lifecycle, the component can maintain internal state, orchestrate complex setups, and share data across its own internal methods. When Langflow triggers a component, the engine initiates a strict sequence. First, before any output generation begins, the engine looks for an internal hook called pre-run setup. You override this method when your component needs to do heavy lifting before the main logic fires. If your component needs to authenticate with an external API, load a large machine learning model into memory, or set up local variables, you place that logic inside the setup hook. Once the setup is complete, the engine moves to the execution phase by calling the run hook. This is where your main payload lives and where the actual data processing happens. Separating the setup logic from the execution logic keeps your code organized and prevents redundant operations. But this raises an immediate mechanical question. How do you pass an authenticated API client or a local variable from the setup hook down into the run hook? You use the context dictionary. Every custom component has an attribute called self.ctx. This is a dictionary attached directly to the component instance. It acts as a dedicated memory bank for the duration of that specific component run. Anything you attach to this context dictionary during the setup phase is immediately available when the engine transitions to the run phase. Let us walk through a practical scenario where the state sharing is necessary. Consider a custom component that processes a stream of incoming documents and needs to output both the cleaned text and a final count of how many documents were successfully modified. First, you override the pre-run setup hook. Inside this method, you access the context dictionary and create a counter variable, setting its initial value to 0. You might also initialize your text cleaning library here and attach it to the context. Next, the engine triggers the run hook. Your method loops through the incoming documents. For every document that successfully passes through the cleaning library, you access the context dictionary, retrieve the current counter value, and increment it by 1. Because the context dictionary persists across these distinct lifecycle method calls, your component safely maintains its internal state. When the run hook finally completes its loop, it can return the processed documents and pull the final, accurate count directly from the context dictionary to pass along to the next node. Mastering the execution engine and component hooks shifts your mindset from writing simple pass-through scripts to building robust, self-contained applications that fully manage their own data lifecycles. If you want to help keep the show going, you can search for devstories.eu on Patreon. As always, thanks for listening. See you in the next episode.